Welcome to Chapter 2. Chapter 1 was all about abstractions for flow of control in a program. Chapter 2 is about data abstraction and the mechanisms we have for that. So that'll be a little bit of a change of pace. And I'm going to start by trying to introduce the idea of what data abstraction is. So up on the screen, you see a very simplified version of counting the number of points in a hand. Simplified, leaving out aces and picture cards, so I could just keep the thing stripped down to its essence. Namely, if the hand is empty, then its point count is 0. Otherwise, we add, but last of hand. So but last is leaving off the suit. So it's the rank of a card of the last card in the hand. I'm doing it right to left only because it makes the example work out nicely. And we add that to a recursive call to total hand for the rest of the cards. So take one card, take how many points it is, add that to the number of points in the rest of the hand. Okay? Simple. The trouble with this is probably completely apparent is, keep doing that. There's this call to but last right here, which means the rank of the card as opposed to the suit of the card. And there's this call to but last here, which means something completely different, namely the rest of the cards. Okay? So the form of the program doesn't really help you understand that. And in particular, if you imagine that this procedure is just one of 1,000 procedures in a big complicated program, and for some reason you decide that you're going to read the hand from left to right instead of right to left, you want to change some of those but lasts to but first, but not others. So you have to find the ones that are about hands and not the ones that are about cards. And that makes things a little complicated. Let me just show you that it works, which it does. So it's 3 plus 10 plus 4 is 17. So now what I'm going to do is rewrite it a little bit. This is basically exactly the same code, the same algorithm. But what I've done is define some synonyms for last and but last. So here, instead of but last, it says card rank, namely the rank of the card, how many points is it worth. And this here, instead of last, we have one card out of the hand. And here we have a recursive call on remaining cards of hand. So not only is this much easier to read, but if I change my mind about how I'm going to go through hands or about how I'm going to represent cards, instead of having to go through all 1,000 procedures looking for every but last and trying to decide which kind of but last it is, I can just change these definitions, either the ones here that are about cards or the ones underneath it that are about hands of cards. Okay? Yeah. If I made an internal definition of those things that are highlighted, it would work, and yes, it would just, like any internal definition, yeah. I wouldn't do that, though, because remember, we're imagining 1,000 more procedures that are all about cards and suits, and I want to use these consistently for all of them. So I wouldn't do it as an internal definition. I would do it this way. Okay? All right. So I haven't really changed anything. I just made up some synonyms, and because of that, I have more readable code, and I have more maintainable code, because I can change one of these two abstractions, namely the one for cards, dividing a card into a rank and a suit, or the one for hands, dividing it into one card and the rest of the cards. Well, the next step, oops, where am I? I'm here. Oh, sorry. So these procedures, card rank and card suit and so on, these are called selectors. A selector for a data type is a procedure that takes an instance of this data type and pulls out some piece of it. So it selects one of the parts, like selecting the rank or selecting the suit of a card. An abstract data type means that it's one that isn't built into the programming language. It exists only in the programmer's mind. So Scheme doesn't know anything about cards or hands. Scheme knows about sentences. And I'm using those words and sentences, and I'm using those to represent cards and hands. So these are selectors. And then the next step is that if I'm going to use these selectors, it's really kind of cheating for me to use a quoted sentence like this as the argument to total hand. Because if I now want to change what a hand of cards looks like, my input to total hand isn't going to reflect the change that I made. So instead of that, what I should do is also make constructors. So here we have the constructor make hand, which is just sentence. And here's make card. And I actually put a little frill into it that instead of just saying HSCD, you can say heart or spade or diamond or club. And it takes just the first letter of that as the representation of the card. So now I can call total hand this way. So let me actually go ahead and load this all up. And now, I mean, this looks like a step backwards because I had to do a lot more typing. Instead of just saying quote 3H 10C 4D, I'm now saying make card 3 quote heart and so on. But again, it means that I can change the representation and my program will still work if I want to. Some programming languages actually provide a feature to let you specify abstract data types in your program and then enforce them. So you can declare some variable to be of type card, and then it won't let you say first or but last of it. You have to say card rank and card suit and so on. Scheme doesn't do that. Knock on wood, there's a new revision in the works that may do something along those lines. But Scheme doesn't do that. And for our purposes in this course, that's a good thing because it kind of makes you pay attention to the abstraction. So the language doesn't act as your conscience. You have to do it yourself. Okay. Okay, now just to make the point, here I'm changing the implementation of cards. I'm leaving hands alone. But now, instead of a word like 3D for the 3 of diamonds, I'm using a number between 0 and 51. And 0 to 12 are the hearts, and 13 to 25 are the spades, and so on. Okay, so if I copy these down, the important point is I didn't change total hand at all. And yet, I can now run total hand and still get the same answer, even though make card for, quote, diamond is now 30 instead of being 4D. Okay, so this is just to prove to you that I can change the representation, and as long as I consistently use the constructors and selectors for my abstract data types, changing the representation doesn't require me to change every single procedure in the program. Okay? That's abstract data types.